Welcome for all in the lecture number 9 of Energy Audit, and in this lecture we will explain about technical assessment of heating, ventilating, air conditioning system in building, and their checklists and their opportunities, and also technical assessment of pumps and their opportunities for pumping system, and finally technical assessment of transport. Okay. The technical assessment of heating, ventilating and air conditioning system in buildings. These systems represent the high significant energy consumption and representing in electricity and in fuel in building such as industry or commercial and even in residential sector. And we have different heat generator systems such as boilers, chillers, distribution system, which include piping and duct systems. So heating ventilating systems are the modern type, of course, are the most reliable equipment and have different features that currently use. As we see in this picture, we have a new equipment that use for supplying the required heating or ventilating or air conditioning system in commercial or industrial. And also, as we see in this picture, we have a complete system for this building, which contains boilers and air conditioning and ventilating system, and the motors have a variable frequency drive in order to reduce energy consumption and increase the performance of the system, and the system having two cooling tower including pumps and fans for producing water cooling and water heating. So the modern system and very important to include in industrial or in commercial buildings. Now we have a checklist in order to reduce energy consumption in heating and ventilating and air conditioning system that applied in building, and this can be used to help agencies in order to conserve energy in different facilities by the following measures, as lowering thermostat settings or checking if there is a match of this system according to the occupancy scheduling, and also lowering the setback temperature. As we see in this figure, there is two types of setback: heating guidelines when the temperature 68 to 70 during occupied hours, and also from 55 to 60 degree for the period of unoccupied period, and also for cooling guidelines such as 74 to 76 during occupied hours, and from 80 to 85 for unoccupied hours. And also this checklist include optimize morning warming up and night setback controls, and also reducing or elimination of major sources of infiltration, and installing a desiccant dehumidification system, and minimize the use of outside air for process ventilation. And also important to educate employees in the facility about these procedures in order to save the energy and increase the energy measures. And also these checklists include check or adjust combustion efficiency of gas-fired equipment, and minimize the use of gas-fired refrigeration equipment, and also controlling the solar gain and that effect on reducing the cooling load inside the building. This is done by a solar shading window in order to reduce the solar gain, and also may include installation of energy efficient lighting and occupancy sensors, and using central heating plants, conduct boiler efficiency tests, and optimizing the combustion efficiency of the boilers, and also maybe perform maintenance and set a maintenance schedule. This is very important for boiler equipment by using scheduled maintenance and continue review for the operation of the boilers, and also checking the quality of water that provided for the boiler in order to prevent the leakage and the corrosion effect inside the piping network of the boiler system. And also this checklist include another issue by optimizing steam plant heat balance, and also minimize the de-rater steam venting, and optimizing the boiler loading. Also maybe include installation of meters on boiler system that make up lines and blow down lines in order to detect any leakage in the piping system, and also maybe include thermal distribution and inspection or replace steam coils and steam trappings in the piping system. And this also may include inspection or repair for condensate return equipment of the boiler systems, and find or locate and or the repair for steam leakage, and repair or adding insulation. Also take the attention about insulation of piping system. As we see, this represents the installation of ducting system for heating, ventilating, air conditioning system, and as we see, this also represents the installation of the piping system from the source of air conditioning, ventilating systems in order to reduce heat loss and increase the efficiency of the system. This of course represents good features and opportunities for reducing energy loss, and also include reduced distribution pressure. Okay, another checklist include temperature of conditioned space. The energy editor must check if it is excessively high space temperature or even low temperature. So he must setting the necessary temperature that will be required for space conditioning. Also required calculation of period for heating or cooling operating, and also a control of temperature and control of the relative humidity inside the space in the building, and also checking for damaged or blocked filters or coils, and that must be maintained or replaced or make the advice about the cleaning of them. Also checking if there is any restricted airflow such as attic grills, and also checking the passing valves, and checking fans and dampers if they are working correctly or not. and also checking water supply and return temperature for heating and cooling applications. Okay. Also, the checklist involve installation of revolving doors and installation LED exit signs. As we see, this is revolving doors in order to reduce the heat loss from inside to outside or from outside to inside the building, and also conduct boiler efficiency test, optimize combustion efficiency, and boiler maintenance scheduling, and also checking the water entering the boiler system in order to reduce the corrosion inside the piping system, and optimizing the steam plant heat balance, optimize boiler loading, and detect any leakage in the piping system, and also inspect or replace steam coil and steam trapping, and inspect or repair condensate return equipment in the boiler systems, and also locate or repair any steam leakage, and repair or add insulation to distribution piping, and so on. So there are many checklists that the energy editors must take their attention about checking these during the process of energy editing. Okay. Now, typical opportunities for heating, ventilating, air conditioning system in different building can summarize by using variables speed controls on fans, refrigerant compressors, and circulation pumps in order to achieve the required demand and their functions, and also review of heating, ventilating, air conditioning system operation controls, and maybe by adapting ventilation rate to occupancy through CO2 controls, and by using heat recovery system such as air-to-air heat exchanger, and improving temperature and time controls, and also trying to lowering air changes inside the buildings, and maybe also by replacing steam heating with low pressure hot water system LPHW systems. As we see here in this picture, we have variable frequency drive system in order to reduce the energy consumption by the motor in this system compared to the traditional motors. Okay. Now, for technical assessment of pumping in different facilities or factories, as we know, pumps represent the largest consumer of electricity in building, industrial processes, and water and wastewater treatment or management. So the energy editor must make their attentions and focusing to check peak flow, and also the head requirement from the pump, and the duration about this peak flow, and also review the design specification of pump and the commissioning sheets and maintenance records, and checking if there is any mismatch between the current working state and the standards of the pumps, and this may be give us the opportunities for improvement if there is any gap or difference between the current state and the pumps when was the first operation in a newly case, and also checking the requirement compared to the design specification, and also checking the visibility if the Top management of the facility will be use alternative pump, and if there is any variable speed drive is applied to the motors that turn on the pumps, and checking also if there is any valves throttled, and checking if the liquid velocity within the typical range or the recommended range or not. And the energy editor also check if there is any parallel pumps with different commissioned values or running or checking the running performance. And also the energy editors will check if there is any standby pumps that will be run in order to assist the pumps in the system. Also, energy editors may be provide evidence of operational problems such as in pumping system, such as cavitation phenomena, if there is any noisy in operation, or there is overheating of fluid, and if there is a leakage in check valves, and if there is a phenomena of liquid hammer, and so on. And also checking if there are any motors overheating and or unclean motors. So, as we see, this is this type of variable frequency drive pumping system. And the typical opportunities for pump by matching the pump operation at the point of maximum efficiency which to the most common load and real state of operation. And also the opportunity if the system has a variable speed drive in order to determine the optimum speed, and if the system has no variable speed drive, here the energy editor may provide advice to consider installation these pumps with variable speed drive, and if there are duty or standby installations, okay, the energy editors may provide his advice to consider one pump for most of time for working, and make the older pump as a standby in order to improve the project visibility in the building. And also may provide advice by using two-port control and variable speed drive pumps instead of three-port control. And also maybe provide about the changing piping system in order to reduce that effect on the velocities and the pressure. So in this case, the changing piping system can reduce the velocity and the pressure drops due to sharp pains or valves locations and so on. And also checking the isolating redundant pipe runs, and also reducing the overall flow and the pressure in the system by using a small booster pump. Okay. Now, technical assessment for transport field. The energy editors maybe provide the opportunities of energy saving by using efficient vehicles or applying good maintenance and scheduling for the current vehicles, and also this related to the driver behavior and the organization commitment and their planning and management in the field of transport sectors. And also required from the energy editor to check the age or and suitability of vehicles for different tasks and the level of data available about the fuel consumption for vehicles and cars inside that related to the specified organization, and review for maintenance regime that applied, and also checking tire pressure and type of tires, and also checking the driver practices by reducing idling time and the driver practices in applying all the required information to reduce energy consumption or reducing fuel consumption, and also review the maintenance and the state of installations, seals, and the age of the refrigerated units of for transported vehicles, and also checking the fuel leakage from tanks or piping system of these vehicles, and so on. So also the opportunities for using new trucks or vehicles that run on electricity motors, which can reduce the fuel consumption and saving energy. As we see, this type of a truck can saving energy or fuel by 30%. Okay. Finally, at the end of this lecture, I say thank you for listening. I hope we'll meet all in the lecture number 10. Thank you and goodbye.